Good afternoon all. Today we are going to see about the instrument notch apparatus, which is coming under the laboratory, Irrigation and Drainage Engineering Laboratory. As you all know, you have theoretically studied about the principles of notch apparatus and the discharge flows and everything. The notch apparatus basically deals with the determination of velocity and also the flow content. So as you can see, this is the notch apparatus which we are using. The lowest part is said to be as the hydraulic bench where the water will be pumped with the help of motor, as I am showing here, and it will get filled at the bench which is right over available at the top portion. Okay, as you can see now, I am oning my instrument and you can directly see that the water level is getting increased. Okay, so as of when the water level increases and reaches the point where this end point of the notch appears, you have to stop the liquid and you have to move this gauge for determining the height of the water. Yes, now I am adjusting the height and I am determining the water with the help of this gauge, and then after which the water gets flowed through the V notch and it gets filled at this liquid, this bench, and it will directly flow to the bench which is to be collected over here. You can see this reading where we have to stop the valve and then measure the time for which each 10 centimeter it takes to climb up. This is how you will calculate the height. This is going to be your H1 and there you are going to calculate the H. With this we will calculate along with the time period. Here usually we will determine the discharge flow and we will comparatively determine the theoretical discharge, and we will compare the value with the help of discharge we have found out over here and then over there. This water usually will get pumped and it will always get circled up to the top portion, and then it will come over the notch apparatus, and finally we will collect it at the output discharge, and then here we will stop our valve. We will determine the value for each 10 centimeter, how much time it takes up, and then we will determine the velocity of the water which is getting flowed down. Okay, this is what we have we will usually see over here. And the next thing is we have three kinds of notch. Okay, so three kinds of notch in the sense, one would be V notch, and the second one is rectangular notch, and the last is circular notch. You will always know about the difference between all the three notches. While comparing that of the V notch, the only difference is the velocity flow will be lesser while compared to that of the other two notches. As you can see, we have determined the height of 10 centimeter. This is the timing which has taken up for filling up the level. So this is how you will determine the time period, and also will determine the flow velocity with the help of notches. Usually we will use notches for determining the discharge, and we will then compare it with the theoretical discharge. And if you want to determine the discharges, most probably we will utilize rectangular notches, since there would be a increased velocity flow while compared to that of the V notches. Now I will show you different types of notches which are available at our laboratory. The first one which we have experimented is V notches, where you have seen that the velocity of flow will be lesser. Okay, the next thing which I am showing you here is the circular notch. This is the notch where we can finally have a greater discharge flow. That is why we are using this kind of notches as our model for pipe water supplies. Okay, so this is why we are utilizing that one. And the next one over here is the U notch. Actually this is wider than that of the V notch, but the only thing is the velocity flow will be not really great, but it would be at a normal state while compared to that of the V notch. Okay, and the last thing which I am going to show you is the rectangular notch. This is also most probably adopted while compared to that of the V notch and the U notches, since it is also wider in nature, but the most commonly used kind of notch would be circular, since the flow will not be obstructed and the flow will be in a greater manner while compared to that of the all other 3 notches. The next experiment which we are going to see for today is the determination of soil moisture with the help of tensiometer. As you all know, the tensiometer will have a dial gauge where we can measure the moisture content. This will be shown as a reading over here, and the main purpose of using a tensiometer is that we have to use this stick for determining the soil moisture instantly for each and every weather conditions. So that means that if you are going to measure a soil moisture at mid summer region, okay, so when you are going to measure the soil moisture content at a noon time, what will happen? The moisture will be really less. Similarly, when you are going to determine the soil moisture at the morning time, then what will happen? The moisture will be more while compared to that of the noon time at the same location. This is what we are going to determine at each and every place, at each and every time, what is going to be the difference in moisture. Okay, this is not a very tedious job to determine the soil moisture. Here we have 4 kinds of stipulating height. Okay, the first height would be 15 centimeter. The first height is 15 centimeter, and the second height would be 30 centimeter, and the fourth height would be 45 centimeter, and the fifth height would be 60 centimeter. What you have to do is, when you are going to measure the soil moisture, you have to dig a hole and then you have to insert your tensiometer at the soil surface for each and every height. The H1 would be your 15 centimeter. After pinning your tensiometer for 15 centimeter, you will get a reading. As you can see, since here the soil content is really dry in nature, the readings are not changed. When you go to certain depth, the reading will change. Okay, so each and every height, that is, first we have to take the reading for 15 centimeter, next for 30, next for 45, and the last would be for 60 centimeter. And each and every time meter, for each and every location, you have to determine for several temperature conditions, that is several time periods. That is how we can compare the soil moisture, and then we will get the comparative analysis at what time the soil moisture would be greater or lesser. This is what we will determine using the tensiometer. Okay, thank you.